Okay, in this video we're going to continue kind of trying to place our ship. So if you remember right, we had up here, we started in our last video, we looked at this problem right here that I've kind of marked. So we've still got our two stations located on the coastline at A and B, 400 miles apart from each other. And of course the ship received a signal from B first, and so that's why we kind of have it placed over here closer to B, but perhaps out of scale a little bit, trying to make it good for the drawing. So what we're going to do in this video is we're going to say, okay, so now we've got a third station here, okay, and it's located out on an island, 300 miles, as it says, 300 miles northeast, north 30 degrees east of station A. So I'm going to kind of make this thing bigger again, because I really just want this part now. Okay, so let's think about C. C sounds like it's probably located, and again, things may not be perfectly to scale, so we'll just put it about right there. Okay. Now, I've kind of went through the math already. You see that I've got the location, but let's just kind of talk about this. So in other words, we know that C is located on an island 300 miles northeast of station A. So we know that this distance here is 300 miles. We also know that it's northeast. Matter of fact, we know that it's north and then 30 degrees east. Okay. So with this, we form a nice right triangle. We know the angle, we know the hypotenuse, and so that's where we can easily determine that C is more or less located, maybe just not quite exactly, but more or less located at this point, minus 50 to 60, as I've indicated right here. Okay. So here's what we want to do then. I want to build another hyperbola, and I've already built a hyperbola that I know the ship is on one branch of that hyperbola using the foci A, using A and B as the two foci. Now I want to pick two others. Considering where I kind of think the rough location of my ship, I'm going to use C and B now as my two foci. And so now I need, as we said, I still need everything eventually referenced on the XY plane, but that is not how I want to build this hyperbola. The first time I just had two foci, so I just drew the x-axis right through A and B, and that we were good. So we have that one still set aside. Now we need to build another one. But to build it, I'm going to actually create, as we've done in the past when we're doing either analytic proofs or whatever, we're going to put a plane or a set of axes on here to make things nice. And so in this particular case, and so bear with me, this is probably going to be a nice squiggly line here. I'm going to put an axis through C, B. Okay. But it can't be the x-axis, and as a matter of fact, it's not going to be x prime, because if you're looking at this, we're going to have to find this one, and then to reference this hyperbola that we're going to build, to reference it in the xy plane, we're going to have to take this hyperbola that we're going to build, and we're going to have to rotate it and then translate it. Okay, so I'm actually going to call this x double prime. Okay, and so then of course it makes sense now. Okay, so I've got these points referenced, still like points C and B are referenced, minus 50, 260, 200, 0. Those are references to the XY plane. I can find the midpoint. Okay, so I'm going to go back here to black here. And the midpoint looks like it's about right there, and we can easily find that. It's the average of the x coordinates, average of the y coordinates, and so we would get that this is, I think it'll be out of the way right here, so 75 130. Now that's a reference in the XY plane. Certainly this point we want it to be simply the origin in our X double prime Y double prime plane. Okay. All right. Now let's kind of put some things down here that we know. So my two foci are C and B. So I do know that the distance between those I can easily calculate, just use the distance formula, or actually what I really want is the distance between B and the center here of, of my hyperbola that I'm building. So in other words, the distance from this point right here, okay, to B. And so in other words, you calculate that, we would get that C, remember C is the distance from the center of our hyperbola to the focus, okay, and so we calculate this, we get roughly 180.35. I'll put that there, okay. And so if you wanted to off to the side, then what we really want then is that, hey, C squared then, okay, is what we're really going to want eventually, is 32,525. Okay? Alright, so that's one piece we need. Now, what we also know then is that, okay, remember we're building this in the X double prime, Y double prime, is that the distance, we need this 2A. Again, that constant difference. Okay, and in this case it's the difference between here and here. Ooh, got a bad line. Now let's go back up here. Okay, so we got this third station C, we read all that. Now what does it say? It says, now suppose the ship receives the signal from B 550 microseconds before it receives it from C. Well, that makes sense in our picture. And you remember from the last one, what that means is, of course, 2A is simply equal to PC minus PB, because we're looking to keep it positive, and that goes along with what we just read. It receives a signal from B before it receives it from C. So it's closer to B than it is to C, and that makes sense. And of course then we have what? That it's simply what? 500, and it gets the signal 550 microseconds before it receives the signal from C. And of course sound, remember, travels at roughly 980 feet per microsecond. So we have that constant difference, 2.8, just like we did before, and we get 539,000 feet, which of course it means, okay, so that's 2A, and you all can do the arithmetic, so that tells me, that implies that A squared, which is actually what I want. Sorry, dog's barking at the UPS. Dog's barking at the UPS guy. Okay. Okay, we're back. We'll try to finish this here. So A squared is equal to 2605.25, since 2A is equal to that 539,000 feet. Okay. Oh, and so now remember that's 539,000 feet, so then we put actually A in miles. I'm not showing all that this time, so actually this is A in miles squared. That's why it's a smaller number. Okay, just remember we do that. I've already did that with C. Okay, and so then from there, okay, we can calculate b squared. That's going to be c squared minus a squared. And so that's going to be 29,919.75. Okay, so in reference to, so our hyperbola in reference to the x double prime y double prime plane, yeah, let's put it right here. Let's put it over here, becomes sloppy. Minus y double prime squared over 29,919.75. Okay? Now, certainly we're not done with this, but we're going to pick it up in the next video. So this is our hyperbola. So we have a second hyperbola. We know the ship is on a branch of it, if you will, kind of draw a picture so we know it's kind of like that. It's on that branch. We also know that it's still on this branch of this hyperbola that we built before, and so we know we'd have an intersection point. But now the problem of it is we've got to get this hyperbola referenced now only in the x double prime y double prime plane. We need to get it, we need to find the equations for this same hyperbola but referencing the xy plane, so we get both things. We get the equations for both hyperbola in the same plane, and then we can look for point of intersection. So we've got, again, we've got a little rotation we need to do and a little translation, and so we'll pick that up in the next video.